Chapter 3, Vectors and Motion in Two Dimensions. Section 3.5, Relative Motion. You cannot determine whether the Earth revolves about the Sun or the Sun revolves about the Earth. Galileo's principle of relativity states that there is no physical way to differentiate between a body moving at constant speed and an immobile body. Amy, Bill, and Carlos are watching a runner. The runner moves at different velocity relative to each of them. The runner's velocity relative to Amy is 5 meters per second. We write this as v sub x with the subscript of RA, which means the runner relative to Amy. The velocity of Carlos to Amy is 15 meters per second, which we write as v sub x with the subscript c sub a, which means Carlos relative to Amy. The velocity of the runner relative to Carlos is then the velocity of the runner with respect to Amy plus the velocity of Amy with respect to Carlos. The A appears on the right of the first expression and on the left of the second. When we combine these velocities, we cancel the A to get v sub x of r sub c, which is the velocity of the runner with respect to Carlos. A factory conveyor belt rolls at 3 meters per second. A mouse sees a piece of cheese directly across the belt and heads straight for the cheese at 4 meters per second. What is the mouse's speed relative to the factory floor? The answer is E. Use vector addition of the two motions to get the resultant motion. Researchers doing satellite tracking of albatrosses in the Southern Ocean observed a bird maintaining sustained flight speeds of 35 meters per second, nearly 80 miles per hour. This seems surprisingly fast until you realize that this particular bird was flying with the wind, which was moving at 23 meters per second. What was the bird's airspeed, its speed relative to the air? This is a truer measure of its flight speed. The figure shows the wind and the albatross moving to the right, so all velocities will be positive. We've shown the velocity v sub x bw of the bird with respect to the water, which is the measured flight speed, and the velocity v sub x aw of the air with respect to the water, which is the known wind speed. We want to find the bird's airspeed, the speed of the bird with respect to the air. We noted 3 different velocities that are important to the problem. V sub x bw, bird with respect to the wind, v sub x aw, air with respect to the wind, and v sub x ba, bird with respect to the air. We can combine these in the usual way. V sub x bw equal v sub x ba plus v sub x aw. Then to solve for v sub x ba, we can rearrange the terms. V sub x ba equal v sub x bw minus v sub x aw, or 35 meters per second minus 23 meters per second equal 12 meters per second. 12 meters per second is about 25 miles per hour, a reasonable airspeed for a bird, and it's slower than the observed flight speed, which makes sense because the bird is flying with the wind. Cleveland is approximately 300 miles east of Chicago. A plane leaves Chicago flying due east at 500 miles per hour. The pilot forgot to check the weather and doesn't know that the wind is blowing to the south at 100 miles per hour. What is the plane's velocity relative to the ground? The figure is a visual overview of the situation. we are given the speed of the plane relative to the air, v sub pa, and the speed of the air relative to the ground, v sub ag. The speed of the plane relative to the ground will be the vector sum of these velocities, v sub pg equal v sub pa plus v sub ag. The vector sum is shown in the figure. The plane speed relative to the ground is the hypotenuse of the right triangle in the figure. Thus, v sub pg is 510 miles per hour. The plane's direction can be specified by the angle theta, measured from due east, and theta is 11 degrees. The velocity of the plane relative to the ground is thus the vector v sub pg is 510 miles per hour, 11 degrees south of east. The good news is that the wind is making the plane move a bit faster relative to the ground. The bad news is that the wind is making the plane move in the wrong direction. A skydiver jumps out of an airplane 1,000 meters directly above his desired landing spot. He quickly reaches a steady speed, falling through the air at 35 meters per second. There is a breeze blowing at 7 meters per second to the west. At what angle with respect to the vertical does he fall? When he lands, what will be his displacement from his desired landing spot? The angle of the skydiver with respect to the ground is the vector sum of 35 meters per second down and 7 meters per second to the west. The angle with respect to the vertical is the inverse tangent of 7 meters per second divided by 35 meters per second, which is about 11 degrees. The skydiver moves horizontally at a constant speed of 7 meters per second for the time it takes to fall. The vertical motion takes 1,000 meters divided by 35 meters per second, which is 29 seconds. The motion to the west is 29 seconds times 7 meters per second, or about 200 meters.